In 1909, a British physicist named Geoffrey Taylor did something deceptively simple. He fired particles of light, photons one at a time, toward a plate with two small slits. What he expected to see was logical, predictable, Newtonian. What he actually saw shook the very foundations of science forever. Each particle, traveling alone, with nothing to interact with, created an interference pattern as if it had passed through both slits at the same time, as if it somehow knew it was being watched. And here's the part that's going to make you pause this video and take a slow, deep breath. When scientists placed a detector to find out which slit the particle passed through, the pattern vanished. Reality changed. The particle stopped behaving like a wave and started behaving like solid matter, simply because someone was watching. This isn't philosophy. This isn't spirituality. This is experimental quantum physics replicated in laboratories around the world for over 100 years. And the question nobody has ever asked you, the one that will completely change the way you live your life, is this. If reality behaves differently when it's being observed, what happens when you observe your own life? I know what it feels like to wake up on an ordinary day and sense that something is off. Not sadness, not anxiety, just a quiet, nagging discomfort. Like your life is a play you're watching from the back row, unable to step onto the stage. You go through the motions, play your roles, follow the scripts the world wrote for you. But somewhere deep inside, a voice whispers, "There's something bigger here that I haven't seen yet." What if I told you that quantum physics, the most precise science humanity has ever produced, confirms exactly that? That you are not a passive observer of reality, but an active participant in its creation. What you're about to discover today isn't motivational theory. It's science. It's consciousness. And it just might be the turning point you've been waiting for without even knowing it. If you've made it this far, you can already feel that this is different. Subscribe to the channel right now, because what comes next goes deep, and you don't want to miss a single second. Imagine you're rolling marbles at a wall with two holes in it. The marbles pass through one hole or the other, and on the other side you see two parallel marks on the wall, exactly what you'd expect. Now imagine replacing the marbles with water waves. The waves pass through both holes at the same time, meet on the other side, and create an interference pattern, alternating bands of light and dark like a zebra's stripes. That's classical physics, predictable, logical. The trouble begins when you replace the marbles with electrons, or photons, particles from the quantum world. You'd expect to see two marks, just like the marbles. Instead, you see the zebra stripes, as if each particle, traveling completely alone, passed through both holes simultaneously and interfered with itself. At its most fundamental level, matter doesn't behave like a solid thing. It behaves like a wave of possibilities, like pure potential. Nobel Prize-winning physicist Richard Feynman, one of the sharpest minds of the 20th century, once said that the double-slit experiment contains the only mystery in quantum physics, not one of the mysteries, the only one. Because everything strange and inexplicable about quantum mechanics is contained within this single, deceptively simple phenomenon. An electron, when it isn't being measured, exists in superposition. It's literally a cloud of probabilities, a wave spread across space, capable of being in multiple places at once. But the moment you try to pin it down, the moment you install a detector to see which slit it passes through, it collapses into a single point. The magic disappears. The interference pattern vanishes. The particle chooses a path as if it knew it was being watched, as if the act of observation itself were a physical event capable of changing reality. And now comes the most shocking part of this experiment. It has been performed with entire molecules. In 1999, researchers at the University of Vienna, led by physicist Anton Zillinger, who would later win the Nobel Prize in Physics in 2022, reproduced the experiment using Buckminster-Fuller molecules, C60 structures made of 60 carbon atoms, large enough to see under a microscope. These structures, far larger than electrons, also produced an interference pattern when left unobserved. And when scientists tried to detect which path the molecules were taking, the pattern disappeared once again. The boundary between the quantum world and the macroscopic world we live in is far thinner than we've been told. And that discovery leads us directly to the concept that will reshape everything you think you know about reality: the collapse of the wave function in quantum mechanics. Before it's observed, a particle doesn't have a specific location. It exists as what physicists call a wave function, a mathematical equation that describes every possible position the particle could occupy, each with a certain probability. It's everywhere at once in potential. That's not a metaphor. That's not a figure of speech. It's the most mathematically precise description science has ever produced to describe nature itself. Erwin Schrödinger, one of the founding fathers of quantum mechanics, formalized this idea in 1926 with his famous wave equation. What he described was deeply unsettling. Reality, before it's measured, is a superposition of all possible states at once. It isn't this or that, it's everything simultaneously. The collapse happens at the moment of measurement. When an instrument or an observer interacts with the particle, the wave function collapses. That entire cloud of possibility condenses into a single concrete reality. The particle chooses a position, and here's a detail physicists are still debating to this day. What exactly causes that collapse? Is it the measuring instrument? Is it the information that emerges through the process? Is it the consciousness of the observer? In 1957, physicist Hugh Everett proposed that collapse never actually happens, that all possible outcomes continue to exist in parallel universes, in what became known as the many worlds interpretation. But for the purposes of what we're exploring here, the most important takeaway is this. Before it's observed, reality exists as possibility. Once it's observed, it becomes concrete fact. But there's something even deeper here, something that's going to stay with you for days. If reality exists as pure potential before observation and collapses into something concrete afterward, what does that mean for your everyday life? Think about your fears for the future, the things you dread might happen. Today, they exist as wave functions, potentials, probabilities, not facts. Think about your projects, your dreams, the different versions your life could take. They too exist as waves of possibility. What if the quality of your observation, your intention, your emotional frequency, the level of consciousness you bring to those possibilities could influence which collapse actually occurs? We're no longer in the realm of speculation. We're in the space where science and spirituality begin to speak the same language. And the next topic will reveal who or what the observer actually is. The word observer in quantum physics is one of the most misunderstood and most meaning-laden words in all of science. For a long time, physicists tried to downplay its significance, insisting that the observer was simply a measuring instrument, just another piece of physical equipment. But as experiments grew more sophisticated, that explanation became harder and harder to defend. Physicist John Wheeler, one of the greatest cosmologists of the 20th century, and mentor to figures like Kip Thorne, went further than any of his peers dared to go. He proposed that we live in a participatory universe, one in which the universe doesn't simply exist on its own, but where conscious observation is necessary for it to manifest as reality at all. Wheeler went so far as to declare, no phenomenon is a real phenomenon until it is an observed phenomenon. That's not poetry. That's the conclusion of decades of theoretical physics. Wheeler pushed even further with his thought experiment known as the experiment. Imagine a photon traveling through space for billions of years. At the moment it reaches your detector in the present, you decide how you're going to measure it. And the result of that measurement retroactively affects how the photon behaved in the past, as if the present could reach back and reshape what already happened. This experiment was actually carried out in a real laboratory, and its results confirm Wheeler's theory exactly. And that forces us to ask a question physics still hasn't fully answered. If the observer influences not only the present, but also the past, what kind of entity is this observer? You are not a spectator of a reality that was already finished before you arrived. You are an active participant in a reality that takes shape as you observe it. And now comes the part that ties all of this to what you feel on the inside. The oldest spiritual traditions in the world, from Tibetan Buddhism to Hindu Vedanta, from indigenous wisdom to the mystical schools of the West, have always described consciousness not as a product of the brain, but as the very foundation of reality. Physicist and philosopher Amit Goswami, professor emeritus at the University of Oregon, spent decades articulating exactly this in his landmark work, The Self-Aware Universe. For Goswami, consciousness doesn't emerge from matter. Matter emerges from consciousness. It is the primordial field from which all physical reality takes form. This isn't mysticism dressed up as science. It's a serious philosophical interpretation of quantum data, taken seriously by respected physicists around the world. And if it's true, it changes everything about who you are and what you're capable of creating. Quantum mechanics is the most tested and confirmed theory in the entire history of science. Its calculations are accurate to more than 10 decimal places. But there's a profound problem. Nobody agrees on what it actually means. There are at least 10 different interpretations of quantum mechanics today, and the greatest physicists in the world remain deeply divided over which one is correct. The interpretation most commonly taught in universities is the Copenhagen interpretation. Developed primarily by Niels Bohr and Werner Heisenberg in the 1920s, it essentially says that the wave function collapses at the moment of measurement and that it makes no sense to ask what exists before measurement. All that matters are the observable results. It's a pragmatic stance. It works, so don't ask why. But there are interpretations that reach far beyond that. Hugh Everett's many-worlds interpretation suggests that every time a wave function could collapse into two different outcomes, the universe actually splits. You live in one branch, and another version of you lives in the other. There is no collapse, only an infinite multiplication of parallel realities. Then there is David Bohm's interpretation of the implicate order, one of the most brilliant and underappreciated physicists of the 20th century. Bohm proposed that there exists a deeper, interconnected layer of reality, of which the universe we see is only a surface projection, like a hologram. For Bohm, consciousness and matter are not separate. They are two aspects of a single reality enfolded upon itself. And here's what's even deeper about all of this. What every one of these physicists shares, from Bohr to Everett, from Wheeler to Bohm, is the recognition that reality is simply not what it appears to be. The solid, predictable, mechanical world that Newton described as a convenient approximation useful for building bridges and calculating trajectories, but fundamentally incomplete. At its deepest level, reality is fluid, probabilistic, non-local, and somehow dependent on observation. David Bohm wrote in his book Wholeness and the Implicate Order that the universe is an undivided whole, in which everything is in a constant state of movement and interconnection with everything else. If that's true, and the experiments strongly suggest that it is, then the next topic on consciousness isn't a speculative leap. It's the logical next step. We've arrived at the deepest point in this video, and perhaps the deepest point in your life. If you allow this idea to truly land, the connection between quantum mechanics and consciousness isn't new. Nobel Prize-winning physicist Eugene Wigner was one of the first to formally propose that human consciousness plays a special role in the collapse of the wave function. In G's famous 1961 thought experiment known as Wigner's Friend, he posed a paradox: two observers in different positions could each have equally valid yet contradictory descriptions of the same particle, unless consciousness itself were the factor determining which reality collapses. This idea was dismissed for decades. Today, it's being revisited in earnest by cutting-edge researchers around the world. Amit Goswami, in the Self-Foy universe, articulates this beautifully. We are like antennas of a cosmic field of consciousness that folds back upon itself to observe itself. Every thought you have, every emotion you experience, every intention you carry, all of it is an act of observation. And if observation influences reality at the quantum level, then the quality of your consciousness, the depth of your attention, the emotional coherence with which you move through your life, all of it is literally participating in the construction of your reality. The Hartmouth Institute, across decades of published research, has demonstrated that the electromagnetic field of the human heart is detectable several feet outside the body. Cardiac coherence, a state of emotional balance and clear intention, produces measurable patterns that influence the biological systems around us. You are not simply a being who thinks, you are a field that radiates. And here we arrive at the synthesis of everything we've explored today. You are not a passive observer of a reality that was created without you. You are a consciousness that is constantly collapsing possibilities into experiences. Every time you direct your attention toward something with fear, you're observing through the filter of fear and collapsing possibilities that are consistent with that state. Every time you direct your attention with clarity, intention, and openness, you are participating in the creation of a different reality. This isn't surface-level law of attraction. This is physics interpreted with rigor and philosophical depth by minds like Goswami and Bohm. David Bohm once said, "The difference between matter and consciousness is not as great as it seems." And perhaps the greatest transformation available to you isn't changing the world out there, it's changing the quality of the gaze you bring to it. You made it to the end of this video, and that tells me something about you. Not everyone is willing to sit with questions as large as what is real. And who am I when I observe? But you stayed, you moved through quantum physics, wave function collapse, the minds of Wheeler, Bohr, Bohm, and Goswami. And you've arrived here carrying a truth you can no longer ignore. Reality is participatory, and you are the participant. The observer effect isn't just a laboratory experiment. It's the most precise description science has ever produced for what spiritual masters have always called conscious creation. The question that remains is yours. With what quality of consciousness have you been observing your own life? If this content stirred something in you, drop your comment below. Tell me, what are you going to start observing differently in your life from this moment forward? Like this video, share it with someone who needs to hear it, and subscribe to the channel if you haven't already. In the next video, I'll take you beyond the observer effect into what physicists call quantum non-locality. The discovery that two particles separated by billions of light years can communicate instantaneously, and what that has to do with love, connection, and the people you carry in your heart even when they're far away. You won't want to miss it.